we're going to do question 11, where we have Harry shoots arrows at a target board, right? He has 50% chance of hitting the bull's eye on each shot. So 11.1, calculate the probability that Harry will hit the bull's eye in the first shot and his second shot. So let's first draw this tree diagram. So we're having two things here. B will stand for bull's eye, and then N will just stand for no bull's eye. So meaning that won't be shooting or won't be hitting the bull's eye here, right? So it's gonna be B and it's gonna be N, right? So the chance of hitting the bull's eye is 50%, so it's 0.5, right? And here it's also going to be 0.5 because the branch of a tree must be equals to 1. The probability of the branch must be equals to 1. So this is the first shot. So you can say this is the first shot. You either hit the bull's eye or you don't hit the bull's eye. And then, so we just want to know the probability that Harry will hit the bull's eye in his first and second shot. So if we consider the second shot, where we have the bull's eye and no bull's eye, so it's still going to be a 50% chance of hitting, and we're also going to have the bull's eye here and no bull's eye, so 0.5, which is 50%, 0.5 here, right? And so it says, so for us to be able to calculate the probability that Harry will hit the bull's eye in his first and second shot, we need to look at this situation here. So this is where he hits the bull's eye in his first shot. This is where he hits the bull's eye in his second shot. So the probability that he hits the bull's eye in his first shot and second shot is equals to B and B, which is bull's eye, right? Because you cannot choose this one because it means now that in his second shot it missed, right? So the second shot, we're going to consider only this and this one here, which is 0.5 times 0.5. So the probability that he hit the bull's eye is going to be 0.5 squared, which will give us a solution of 0.25. So 0.25 is the answer for this problem here. So 11.2, calculate the probability that Harry will hit the bull's eye at least twice in the first 3 shots. So at least twice. So at least twice means twice and 3 times, or to the maximum number of shots, right? So they said in his first 3 shots, so which means we need to include another shot. So here it's going to be the bull's eye and N here, so it's going to be B and N here, and here it's going to be B and N, and here it's going to be B and N. So it's going to be 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, 0.5, and 0.5. So we want to find the probability that at least 2 shots to the bull's eye, right? At least he has 2 he hits the bull's eye. What is it saying? He hits the bull's eye at least twice, right, in his first 3 shots. So where if we look at, so this is going to be the third shot. Let me just indicate third shot, right? So hitting the bull's eye at least 2 times. So when they say at least 2 times, it can be 2 to the maximum. So our maximum here is 3 times, right? So it's 3 times. So it's either in this tree diagram you're going to choose 2 times or 3 times. So hitting the, let's first start with the maximum. Hitting the bull's eye 3 times would be this B here, and this B here, and this B here. So that is 3 times. So which means the probability will be equals to B, B, and B, right? Plus, and then there's no other 3 times, right? So meaning that we just need to consider 2 times now, right? Because it's at least 2 times. So for hitting the bullseye twice, it can be this one here, and then the branch goes to this end which we don't hit, but you also hit here, right? So it's going to be B multiplied by N multiplied by B, right? And then so we are done with this one here, and then another way is you will still, let me see, no, this one is out, considering this N, but you still hit twice, right? So it's going to be plus N B B, right? Or another option would be, so we are done with this one here, and we are done with this one here, and we are done with this one here. Cool. So it means now that we just need to, there's one missing though. Let me see. So if this is done, if we're done with this, and did we consider this BBN? Let me see. No, yes. So we missed this one. So this one here, let me just use another color. Let me say, okay, this one here, okay, no, and this one here and this one here. So BBN, right? Plus BBN. So now we have the probability of at least 2 shots. So anything else is not at least 2, it's just below that, right? So then to find the value of BBB, we know B is equal to 0.5, so it's going to be 0.5 multiplied by 0.5 multiplied by 0.5, right? So for this one, and then plus for this one here would be 0.5 multiplied by 0.5 multiplied by 0.5, right? And then for this one here, so this is done, it's going to be plus 0.5 times 0.5 times 0.5, right? We're done. And then for this one here, it's plus 0.5 times 0.5 times 0.5, right? And then we are going to add all these products here, right? So it's just going to be 0.5 times 0.5. Let me write it properly. So it's 0.5 times 0.5 times 0.5 multiplied by 4, right? And the answer that you need to get for this problem here is 0.5, right? As your answer. Let's now go to another question. So another question says that in 11.3, Glenda also has a 50% chance of hitting the bullseye on each shot. Harry and Glenda will take turns to shoot an arrow, and first person to hit the bullseye will be the winner. Right? Calculate the probability that the person who shoots first will be the winner. So the probability that the person who shoots first is a winner, we're going to find it by first identifying that the probability of hitting the bullseye is this one here, plus the probability of hitting the bullseye is going to be 0.5 to the power of 3 plus the probability of hitting the bullseye is going to be to the power of 5, right? So now we're just going to find because this is a sequence of shots, right? Sequence of shots. So we're going to find the probability using the sum to infinity, right, of a over 1 minus r, right? So our a value in this case is going to be 0.5, right, divided by 1 minus our r is going to be equal to 0.5 to the power of 3 over 0.5, right? So it's 0.5 to the power 2, so it's 0.5 to the power 2, and then a probability, if you punch it in your calculator, you should get 2 over 3. So that is our answer for this problem here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.